Hello everyone! Today on my table we have new product by BTT. It is Hermit Crab version 2 Quick Change Toolhead System, which allows you to extend functionality of your 3D printer and add opportunity to fast swap toolheads. Let's say you want to use laser engraver or vinyl cutter, or you have custom toolhead to print with specific materials. BTT released two versions of this product, standard version and CAN version. In my case, company have sent me CAN version, and in order to use it, you will need separate CAN extender model or motherboard that support CAN bus protocol. There are a few benefits in having CAN bus version, as it has extra hardware such as max digital converter. We also have onboard accelerometer, and we also have onboard motor driver, so you definitely will get extra functionality and flexibility with CAN plate. Meanwhile, CAN bus version at this point only supports Clipper, while standard version can be used with Marlin and RepRap. I personally prefer to have CAN version, as you don't really need to care about bunch of cables going to your toolhead, and all communications are happening via simple 4-wire cable. 2 wires for power and 2 wires for CAN low and high signals. Let's open the box and take a look what we have inside. Very similar experience to Apple phone opening. There you go. We have a documentation. You can install this device without even looking at the internet, which is very nice. I'm happy to see that. Those are the plates you mount your toolhead. They are actually very light. 1, 2, and third one installed directly on the Hermit Crab itself. The detachment is very simple. You just push the button and release it. We're gonna put it back for now while we're unboxing and take a look what we have further into the box. We have a rubber duck, a few stickers, and some accessories for the device itself. 1, 2, nothing more. Okay, let's open this box. You have right here cables for the device. So here's the CAN cable, and that's what I was talking about. You have 4 cables. Those are for your CAN signal and power that goes to the plate itself. This box contains plates and extra parts. Nothing else in there. You have all the tools that you will need to install it, zip ties, nice to have. And we have extra parts like POM wheels and the brackets. First one is for MGN9 and MGN12 rails, and the second one for the POM wheel setup, similar to Ender 3. Let's take a closer look to the plate. This is the plate you mount your hardware on. Here's the fan connector, other extension ports like a fan and everything else. You have LED connector, and we have right here opportunity to plug in IC2 devices like sensors or something else. And let's take a look at actual main board. Again, the release is pretty simple. You push the button and that's how everything connected via those spring-loaded pins right here. The board is driven via RP2040. This is Raspberry Pi chip, and you have USB-C. We have opportunity to connect end stop or filament run out sensor. I see some LEDs installed right here, and pretty much the whole setup is way lighter than I expected. Okay, I have took my dusty Ender 3 Pro from the shelf, and we're going to install Hermit Crab 2 on it and BTT E3EZ motherboard with new drivers and CM4 model by Raspberry Pi to run Clipper, and it also supports CAN bus. This is already a modified Ender 3. I have all metal hot end in there, I have ABL sensor, and we have fake bond edge extruder with small motor out there. So let's take this printer apart. We will get rid of everything right here, install the Hermit Crab, and we will replace the motherboard. Let's get it to work. So at this point I have disconnected everything. This guy right here is going away. We will replace it with the plate and CAN bus wire, and let's keep replacing the motherboard. I just finished the configuration of my Manta E3EZ with Hermit Crab running via CAN cable. Some people will find this configuration very frustrating, and I will make separate video how to configure Manta E3EZ to work with CAN devices. Scrolling to GitHub repository for this motherboard, I have found that BTT provides you an STL if you want to mount it on Ender 3. I have used 3mm drill, drilled the holes right here, and put brass inserts. Everything right now mounted with the bolts. I will have to unscrew this original plate. We need to connect all the wires for the motors, and only after that we can install this new plate on. It's worth mentioning that comparing those two plates, you have access to USB ports right here, so you can use angled cable, and also right there you don't have that problem where SD card is sticking right in the middle of the bolt. So I took out the extruder motor and extruder itself, and we're going to replace Bowden setup with direct drive on the plate. I have used crimps on end of those connectors. Looks like you cannot install this motherboard with crimped wires. So I will probably go with factory solution for Ender 3 solder connectors. Those are not the best, but that's the only solution in this case we are able to afford. Right now with soldered joints, you can see that we have plenty space. I have mounted the plate. We only need to figure out how we will pass the wires right here. This is, you can see it's actually toggling very sharp corner right here. Better to maybe print something right here, like insert, that way those cables are not going to be cut here. Here's our power supply. We have plus and minus extra terminals available over here. I stripped original CAN bus wire. We'll cut it right now. One piece I will crimp with U connectors right here. Another piece I will connect with XT Tori connectors. So our CAN bus will be served via XT Tori connectors to the toolhead. I have made a cable, XT Tori connector, and we have little Y connectors that I will put right there right now. Our 3D printer is ready to put plate on. Following the documentation, we need to take existing plate out, and 4 wheels are gonna drive our main plate. The first step for us to install those two M35 screws, M525 screw, the palm wheel, the spacer, and we screwing it back from behind. And here's the first mess up by BTT. In my original kit that I got, I had wrong hardware. I just opened a second kit. You should have 2 bolts 528 and 2 bolts 525. The spacers have to be the same. In my case, spacers are different. Here's what I got in my first package, and here's what I got in the second package. Here's assembly, 2 bolts 528, spacer, and the palm wheel. And we're going to screw them with the nuts. Now you can see the bracket is wobbling, and we need to use that key in order to turn concentric nuts on the bottom in order to make it be in a proper condition. Here is another problem with this kit. We have belt clippers and they are rubbing against the wheels. I'm going to seek for a solution in order to make it work. Alright, at this point I have spent a little bit of time tightening the wheels, and both of those wheels are mounted with concentric nuts, so you can over tighten it. This way it will touch the bracket, and keep turning it while you find the perfect position of tightness of the wheel, and that wheel shouldn't touch the bracket on the sides. I had to get rid of those brass inserts because they were touching the wheel and scratching it. Here I have little zip ties, and I probably will print some inserts here from ABS, that way they can hold the belt. Other than that, the way I tighten the wheels, I always give the opportunity so I can hold the wheel and turn the top wheel or a bottom wheel with the hand, but it shouldn't be easy turn. You should be like barely able to turn it, and we don't have any wobble over here. I also worked a little bit on the cable. I have mounted right here with zip ties, so at this point it's able to travel both directions, and we can go in the lowest position, and it's perfect right there. a little bit higher. Here how everything looks when gantry all the way up. The wheel is touching the extrusion right here. Cable is perfectly on the place. This is the highest position and we haven't lost any Z. My problem is that on all other 3D printers I have CAN bus, I am using special bracket to hold this piece, and over here on the sides we have threaded holes, so we can probably make a 3D print that will hold this piece sturdy, but it is very stiff at this point and I'm not sure I will need to do it right now. We are going to start running the printer and then we will see if we need to do extra adjustments. During final adjustments of the 3D printer, I realized if I want to run plotter mode or cutter mode or even laser engraver, I will need Z end stop. This is original Z end stop that came with Ender 3. I haven't been using it due to afterbed leveling probe being installed here before, but now we have it. I installed it on the side instead of being on front of the printer, and it is homing with that little plate that holds the wheel without any problems. Let's talk about final wiring. We have 3 motors for X, Y and Z with 3 correlated drivers. We have CAN bus, X, Y and Z end stops. I have thermistor for the bed connected right here. Fan for the cooling of the motherboard connected right here. And we have incoming power and power bed coming into those screw-in terminals. This is our power for toolhead coming directly from the power supply. Everything right here secured from being scratched from this sharp extrusion. I think I will 3D print later something right here, but now as a proof of concept, that's how it is. This is our first power up after I assembled everything. The only thing I need to do is prepare the plate and start using the plates. So overall printer is fully assembled. Let's start our printer. No magic smoke and I see the lights is getting on right here. First thing we run with this mod will be this extruder. I have multiply negative things to say about this extruder, but that will be a separate video. Behind the camera I have assembled our Hermit crab plate. We have simple extruder, we have thermistor, our motor directly drives from the Hermit crab, and little fan. We don't need part cooling fan for few simple tests right here. Let's install it. Installation is pretty straightforward. You just line it up, those 2 little guys on the bottom holes, and just push it in. That's it. That's simple. That's the whole purpose of having hot swap tool heads. Again, if you want to switch it, you just push the button on top and take it out. Now you can see my machine is printing perfectly fine. I have leveled the bed, adjusted extruding distance, adjusted all the settings in the clipper. You will find my configs in my GitHub repository if you want them. The print is done, and if you want to see second part for this Hermit Crab 2 setup, where I will try all sorts of different plates, leave your like, subscribe, and I see you at the next one. Bye bye.